Hi, I'm Iain and welcome back to the Northland Workshop. One question I get asked all the time is what tools do I need to get started in woodworking? Because let's face it, you open any woodworking magazine and it's just tool ads out the wazoo. You've got tool reviews out the wazoo. It seems like in order to do woodworking you need an entire shop full of tools. And if you do woodworking long enough, chances are you're going to end up with a shop full of tools because that's just the way it goes. But it can be intimidating starting out because it looks like in order to do anything, you're going to need tons and tons of tools. So what I've done is I've studied the projects that I've made in the past and I've boiled it down to the 5 tools that I use most often. And if somebody was to tell me I could only have 5 tools in a shop, or I was setting up a brand new shop, these are the first 5 tools I would have in it. So if you're new to woodworking and you just don't know where to start with tools, I think with these 5 tools you're going to be able to do 95% of all the projects you want to do. Are the other tools nice and do they give you more options and flexibility? Yes. But for a lot of things, you really don't need them if you take your time with these other tools. So let's start at number 5. Number 5 on the list is a router. And I've got 4 different routers out here to show you some of the differences. You can get what's called a fixed base router where there's no plunge mechanism to it to adjust the height. You unlock the clamp, and on this one you rotate it. Sometimes you rotate a ring or a knob on it, but whatever it is, the adjustment mechanism is slow and you adjust the height of the bit sticking out the base before the cut starts. You can't make a change on the fly or in the middle of a board. This one is the conventional style with the 2 knobs on the bottom of the base to guide the router. This one is another style. It's called a D handle because it has a D handle kind of like a circular saw has. And this just gives you a little bit more stability. However, the issue with these is that they're primarily designed to start the cut at the edge of a piece of wood and end the cut at the edge of a piece of wood. They're not good for starting a cut in the middle of the board or ending the cut in the middle of the board. Yes, you can do it with a fixed base router, but it's not designed for that. So, if you're only going to have one router, I would recommend putting aside the fixed base routers for a second and we take a look at the plunge routers. These two are 2 horsepower plunge routers. These are considered mid-size plunge routers. You can get them all the way up to 3.5 horsepower, but that's a very big bulky router that's better suited for a router table than general purpose use. A 2 horsepower plunge router will have all the power you need for handheld routing, and if you get a router table someday, they're more than adequate for 99% of all router table jobs as long as you take multiple passes. The plunge router gets its name because it has these guide rods that allow it to slide up and down. You've got various ways to adjust the overall depth of cut, but the big thing is you have a lever in the back that you can pull and you can plunge the bit straight into the workpiece, so you're no longer limited to starting it at an edge or ending at an edge. You can start in the middle, plunge down, route until you're done, and then simply retract the bit again. But it's really not enough to just limit it to getting a 2 horsepower plunge router. There's a couple other features you need to look at when choosing a plunge router. In this case, this one has a 1/2 inch diameter collet. That means it can take 1/2 inch shank router bits. That's good. You also want to be able to have it take 1/4 inch shank router bits because 1/4 inch and 1/2 inch are the 2 common router bit sizes, and you'd be limiting yourself if your router could only take one size or the other. So with this one, it has the 1/2-inch collet, and they supply you with this little reducer bushing that goes from 1/2-inch to 1/4-inch for the 1/4-inch shank router bits. This one, on the other hand, does not supply you with a guide bushing. It supplies you with a whole extra collet. So here we have the 1/2-inch diameter collet, and then the one I have installed in it is the 1/4-inch collet. So when you're looking at purchasing a router, you want to make sure, whether it has 2 collets or a reducer bushing, that it can handle both 1/2-inch and 1/4-inch diameter shank bits. And that should be included with the thing if you buy it brand new. If it's used, just make sure, whichever manufacturer you choose, that they can still supply you with the other one, because sooner or later you're going to get a router bit that needs that other size collet. Another thing you want to look at is, can this router take guide bushings? And this is a pack of generic guide bushings, and if we open it up, you'll see it's just these brass bushings that have this threaded ring to them. And there's also a threaded ring that goes with it. The idea is, for certain applications, for doing template routing and stuff like that, you'll have a router bit in the center of this, and this collar will actually rub on the edge of the template, following the template, and therefore guiding the router bit. The way these work is they go in the base, and then you simply tighten down the knurled collar. Well, you want to make sure that whatever router you get can take guide bushings in the base. This is very important if you ever plan on using the router in a dovetail jig, because they all require the use of guide collars. This one, for instance, the manufacturer does not supply an adapter to be able to use guide collars. You would have to purchase an aftermarket base, and I've tried those before. They don't tend to work real well on this particular router. So just be aware, when you buy a router, you want to make sure it can use both sizes of bits, and that it can use the guide collars. So just be aware of that. If you have a 2 horsepower plunge router that can take both 1/4-inch and 1/2-inch bits and can take guide collars, it will do everything you want a router to do in a one router shop. Coming in at number 4 for my most essential power tools would have to be the lowly circular saw. I use a circular saw on every project that requires some sort of sheet good, whether it's plywood, MDF, or melamine. If it's a big 4x8 sheet, the first thing that I break it down with is a circular saw. So if you're in the market for a circular saw, and you're in the market for a circular saw for woodworking, this thing right here, the worm drive saw, is not for you. This is an excellent saw. It has all the torque you could possibly want to cut wet, pressure treated 2x material all day long on the job site and never give up. But it is almost 20 pounds of circular saw, and it is just too much saw for woodworking. This is major overkill for anything we would ever build in the workshop. Even the occasional deck job, really, this thing is made for framing houses all day, every day. Plus, it's expensive. So, worm drive saw is out, and we are left with what's known as sidewinder saws. And I've got 2 examples of them here, a corded one and a cordless one. And really, if you're doing stuff in the workshop, it doesn't necessarily have to be cordless, because usually in a workshop you've got at least one outlet in there. But The cordless saws have come a long ways in recent years, and if you get a brushless one, regardless of what brand it is going to have almost as much power as the corded version, or in some cases it could even have more power than the corded version. So just be aware, the brushless battery powered saws of today are not like the cordless saws of yesterday. They are every bit as capable as the older style ones. But again, do you need to pay the premium for the cordless saw plus batteries when it's used primarily in a workshop? That's something you have to decide. But what I want to look at for choosing a saw, whether it's cordless or corded, is a couple things that will make it nicer for workshop use. One thing is how light it is. Ideally, you want to heft the saw before you buy it. So if you're ordering it online, I recommend you go to a store and actually hold the saw in your hand before you order it, just to make sure it doesn't weigh a ton like, say, this thing. The other thing you want to look at is some of the refinements that will help for woodworking that doesn't necessarily have to be on a saw for doing lots of rough framing. One of those things is you want to make sure the base plate has a straight edge to it and it's not rolled out of some sort of stamped metal. Like this saw, you can see it's got this big radius here. That makes it almost impossible to use with a speed square to gut straight cuts, because it tries to ride up over the edge of the speed square. Neither one of these saws have that issue because they have cast magnesium bases with a square edge to them. They don't try to ride up on a straight edge. And when I'm breaking down sheet goods, I'm using a straight edge with these things. The other thing you want to check out is that it has some sort of positive stop at 90 degrees. Both of these saws have a set screw that you can adjust that sets the blade 90 degrees to the shoe. Whenever you loosen up the bevel adjustment, bevel it, and then return it to 90 degrees, you get it at exactly 90 degrees again. That's very nice, and it is a pain when they don't have it and you constantly have to fiddle with a square to make sure it's back to 90 degrees. The other thing I really appreciate with saws is some kind of dust collection. Now, no circular saw has perfect dust collection, but if you're cutting down sheets of MDF that makes a lot of dust, you will appreciate any kind of shop vac connection you can get. This one has a shop vac connection that goes on over the standard dust spout, and this connects to a regular 1¼ inch shop vac hose. This one has this little metal spout that can detach, and it goes to a proprietary quarter cable size hose. This one, even though it has the drawback of the proprietary hose size, the nice thing about a corded saw with a shop vac connection is you can get a tool activated shop vac, plug the circular saw into it, and then every time you pull the trigger, the shop vac turns on, and when you let go of the trigger, the shop vac turns off. With a cordless one, you can't plug it in to one of the automated shop vacs, so you have to go over and turn the vac on and off when you start and stop the cut. Not a huge deal, but it's just something to keep in mind. The other thing to keep in mind is if you are getting the cordless saw and then you are tethering it to a shop vac, even if that shop vac is also cordless, you're dragging a big hose around with it. So just be aware of that, that if you're going to tether it to something with a big hose, is it really that big a deal to also have the cord on it? And again, corded circular saws tend to be cheaper than the cordless equivalents. The other thing to look at, be it corded or cordless, is you want a saw that has a brake on it. And what I mean by that is this has an electric brake built in that every time I let go of the trigger, it acts to slow the blade down quicker. And that is handy for making stop cuts in pieces of plywood. Say I'm notching out for toe kicks on the bottom of a bathroom vanity. When I get to the end of that cut, I let off the trigger and I don't have to wait forever for this blade to coast down. The longer it takes to coast down, the longer I have to hold it in position and make sure that I don't try to back it out of the cut, which could wreck the cut or cause it to kick back. So it's a handy thing to have. Now, as far as I know, all the brushless, cordless circular saws right now have brakes built in, so that's not an issue. But if you get a corded one, you just want to make sure that you get one with an electric brake. Finally, speaking of blades, the blade that comes with the circular saw is usually good for framing and not much else. It's a coarse blade. It's usually not the top of the line blade. Even if you get it from the manufacturer and the manufacturer also makes a line of blades, usually the one that comes with the saw is not their top of the line blade. You want a finer tooth blade. This one happens to be a 36 tooth finish blade, and that works out really well for cutting plywood, 1x material, stuff like that. It'll cut through a 2x4 slower than, say, one of these framing blades, but again, that's not what we're here to do. We're doing woodworking with this thing. So a finer blade with more teeth. The other thing is, don't get lulled into the low price bargain blades that are in the little displays at the local home center or hardware store. If it's 24 teeth, it's made for framing, and you're not going to like the cut you get when you cut plywood. At the same time, the 100-something tooth plywood blade is a holdover from days gone by, and you don't need that. If you get a 36 to 40 tooth carbide tip blade from a good brand, and it's in the $20 range, it is going to be light years ahead of any kind of dedicated plywood blade. Plus, you can use it on 1x material as well. And number 3, we have cordless drills. And really, if there's one tool that should be in every single home, it's a cordless drill, because you're going to use it whether you're doing projects around the house like hanging pictures or flat screen TVs, or down in the shop making furniture. And I've got 4 of them here. I just grabbed 4 to illustrate some differences between them and what works and what doesn't work in the workshop. Here we have the 9.6 volt Ryobi drill. This is an ancient thing that is on its 2nd set of batteries, and I use this thing all the time for driving in pocket hole screws. And there's a reason for that. These old 9.6 volt battery drills go at a low speed. At full trigger pull, I only get 550 RPM out of this thing. That's pretty slow. That's what low speed is on most other drills, and that's the fastest this thing will go. That's fine for driving screws. The other thing is, because it's such a slow speed, I get a lot of flexibility with the variable speed trigger. I also really like the clutch on this thing. Now, this drill hasn't been sold for probably 15-20 years at this point, so you're not going to find one of these things new at the lumberyard. But I brought it out to illustrate some things that you might want to look at. Those are the responsiveness of the trigger and the clutch. Like I said, this has a very nice adjustable clutch. This one, on the other hand, has a 5-setting clutch. Now, this thing is actually even older than this one, but what it lacks in clutch, it makes up for in power. This is a 14.4 volt drill. They don't make 14.4 volt NiCad drills anymore, but just like the Ryobi I just showed, this has a very responsive trigger. You can make that chuck spin very, very slowly. That's nice when driving screws, and that's a lot of what we do with woodworking with cordless drills. Now, you can get an impact driver to do that. I have not found impact drivers to be useful in the workshop at all. They're just too powerful, they're too noisy, they tend to destroy things if it's something smaller than a deck screw. So for woodworking projects, leave the impact drivers alone. Look at getting a general purpose drill driver. So again, this thing, it's ancient. It was made in 1998, so it's not even from this century. It's a dinosaur, but it works well, and I really like it for woodworking because it has a very responsive trigger and it has plenty of torque and power to drill pocket holes, and they take quite a bit of power from a cordless drill. Moving into the modern era of lithium-ion batteries and brushless tools. Brushless tools are all the rage, and they're not going away anytime soon. They are here to stay. They are the future. Hooray for them. Maybe. If there's one drawback to the brushless tool, it is that it has a very fast start-off speed. And what I mean by that is no matter how slowly I pull this trigger, once it finally decides it's going to start turning, it's turning much faster than this thing does. This one I can get to just barely creep around. This one, not so much. That is not a selling feature when it comes to installing screws, because this thing, when it starts off, it's off to the races. And once you try installing, say, pocket hole screws with something like this versus one of these two with a much nicer trigger, this thing, you can really start to see how that fast takeoff speed is not a selling feature. Same thing with this one. It has the same, if anything, faster takeoff speed than this drill. So again, the brushless tools are here to stay. For workshop use, I can't recommend them for cordless drills. You can still get brushed cordless drills in lithium-ion battery technology. So you can buy a modern drill that has lithium-ion batteries, takes the same battery as any other cordless tool you might have, but it has a brushed motor, and from what I've found is the brushed drills still have a much slower start speed than their brushless brethren. These things just seem to all start at a very high RPM when it comes to doing very delicate work like driving screws in. So just be aware of that. The brushless tools have lots of power. I haven't found them to have enough finesse for workshop use. The other thing is, when you're getting a cordless drill for the workshop, don't get a hammer drill. It's an extra expense and it's extra weight. The hammer mechanism in there is a lot of metal. It usually makes the drill longer than it needs to be, and it makes it a few pounds heavier than it needs to be. So for workshop woodworking use, you're not drilling into concrete, and why pay more for a feature that you're probably never going to use? So you can get regular drill driver ones that have a clutch, that have the drill setting that bypasses it, but no hammer setting. It'll be a couple pounds lighter than the hammer drill equivalent, and it'll be cheaper than the hammer drill equivalent. Here we have this little 12-volt drill driver. It's called an installation driver, but to be honest, I haven't found it that useful for that because, again, it's just not responsive enough. The trigger does not do what these old triggers, or say a brushed version of this could do. If they made a brushed version of this with a responsive trigger like back in the day, it would be a wonderful tool, because this has all these accessories to it. You've got your regular 3/4 inch keyless chuck, you've got a right angle attachment, you've got an offset attachment, and then you've got a quick change attachment. It is a great system, and this has saved the day several times with pocket hole screws that I could not fit this thing into. But again, the finesse just isn't there. So my recommendation is get a modern brushed drill. It'll be cheaper than one of these, and it has much more finesse to it. And let's face it, we're woodworking. We aren't building houses. We aren't using these for giant hole saws in 2x material. So the brushed life of the motor is probably going to be plenty for us. This thing's from 1998, and as far as I know, it still has the original brushes in it. Coming in at number 2 is pocket hole jigs. And these, especially if you're starting out in woodworking, are going to allow you to make a lot of projects that would otherwise require complex joinery. Now, if you do woodworking long enough, you will probably end up learning the more complicated joinery as you go along, because it is rather fun and you do get bragging rights. But you can make functional furniture with strong joinery using nothing more than pocket hole jigs. And I've got 3 of them here to kind of show the lineup of them. Starting with the most basic is this little 1-hole pocket hole jig that simply gets clamped onto the piece of wood, and then you use the drill with the step bit to drill the pocket hole in the workpiece. The downside to something this simple is you have to line it up with the edge of the board very carefully, and it only drills 1 hole at a time. So if you're doing multiple holes in, say, a face frame that might require 2 holes at the end of each board, you have to clamp it, drill the hole, move it again, clamp it again, drill the hole. This is the most inexpensive method to get into pocket hole joinery, because usually you can get this with the special step bit and the collar, usually around 20 bucks. I don't think the kit comes with the driver bit. You'd have to get that separately, but for $2 more, say $22 total, you have a working pocket hole joinery system. But for most things, other than repairing existing furniture, you want something a little bit faster. And here we have the intermediate hobbyist to small production scale benchtop systems. Now these still use the drill with the step bit, but they make drilling the holes a little bit faster because they have a built-in clamp. They have better repeatability because they've got the stop built in with the bottom, and you adjust it for the thickness of wood. So you have more repeatability, it's faster because you have clamping mechanisms, and it's not scooting around on you because you can either screw it into a workbench or, say, a piece of plywood and then clamp that to the workbench, or with this K5, they've got this recess in the front so you can actually just clamp it to the workbench. You don't even have to screw it to a piece of plywood. This is the K4. You can usually find these with the step bit and the driver bit in a box at your local home improvement center for around $100. I think right now they're on sale for like $74, so that makes this thing even more attractive. However, there is the K5. And the K5, it's a physically bigger jig. It has these outriggers to it, so that way if you're putting pocket holes in, say, a plywood panel for a cabinet, it's not trying to tip off the side, whereas with this thing, you'd have to screw it to a piece of plywood and then make wooden outriggers for it. You can do it. This comes with it in the box. You just end up paying for it. The other thing is, these outriggers have little compartments to hold drill bits. It comes with a little stop block, a little setup gauge, and some other things with it, along with a chart for what screws to use, and that all goes in this little compartment like so. So that's kind of handy. Again, it's something you pay for when you buy the thing versus making it out of some scrap pieces of plywood. The biggest benefit to the K5 has to be this front mounted clamp handle. With the K4, you have to reach around the thing to actuate this clamp, which is fine for 1x material and small things, but if you're trying to do this with a big piece of plywood for, say, a cabinet side, you have to try and reach around that piece of plywood to work the clamp, which isn't a huge deal, but it slows you down. And if you're doing a whole kitchen load of cabinets, that little bit of effort really adds up. Whereas here, you don't have to get to the back side because the clamp works from the front. Now, if there's a downside to this thing, it has to be the price. This is between $50 and $60 more expensive than the K4. The other thing, and I don't know how big of an issue this is, but I have seen on more than one occasion this tool-free ratcheting mechanism that lets you adjust for different thicknesses of wood for this clamp has been known to strip out. Now, out of the hundreds of these sold, I don't know what the figure is on how many of these have stripped out. I've never had a problem with this one, and I've used it quite a bit, but it is one added place that it could break, whereas a tried and true toggle clamp, there's really not much to break on this thing. It's just a little slower to adjust, and you have to reach around the thing. If you're getting into woodworking, I would hold off on the K5, and I would get the K4 when it's on sale. I think that's your best bargain for flexibility, repeatability, and the fact that you can just clamp it to your workbench. So if you don't want to have to mount it to a piece of plywood, you don't have to. This also works well if you need to take it outside to work on a deck or something like that, because there it is, it's not screwed down to anything. You can get different drill guides. This is the micro drill guide. It uses a 1/4 inch step bit versus the 3/8 step bit of the standard drill guide. This drill guide fits right in the existing holder, so you just take this one out, put this one in, and you have your thickness graduations on here just like the regular drill guide. And there's a plug hole cutter and some other things that you can get for these as well. Same with the K5. All the things are interchangeable between the K5 and the K4, so you have tons of flexibility with either one. If you get a bunch of accessories for your K4 and someday decide that you're using it enough to warrant the K5, well, don't worry, all your accessories for the K4 can go to the K5. It's just nice to have options. They both have the option for dust collection. You can either get the port that snaps on here, depending on the features that come in the kit that you get this in. A lot of the times they will include the dust port, but not always, so that's something to be aware of. As far as I know, the K5 is always offered with the dust port. It's got this little swivel to it for what it's worth. It does make a big difference to have a shop vac hooked up to these things. It makes a lot of dust, not fine dust that gets in the air, but just chips that make a great big mess. It's amazing how much of a mess these things can make if they're not hooked up to a shop vac. So, this is the best way I know of to introduce people to woodworking in terms of joinery. It's not perfect for everything, but it's good enough for a lot of projects that you'll get more comfortable with woodworking in general, and then you can expand your knowledge of joinery to, say, mortise and tenon and stuff like that. But this is a good way to start, and for 70% of the projects, this is a perfectly acceptable joint that will work for a long, long time. Okay, now it is on to my number one tool. So here we have my number one tool, and this comes as a surprise to a lot of people because they automatically think I'm going to say table saw. Well, no. I like the Radial arm saw. It is way more flexible than a table saw, and if I could only have one stationary tool in the workshop, it would be the Radial arm saw, hands down. 85 to 90% of all the cuts I make on work pieces, building furniture, are done on either this saw or the Radial arm saw behind it. The reason for that is most things for woodworking end up being cross cuts. I do a lot more cross cutting than I do ripping, and these things excel at cross cutting. Whereas a table saw, you have a stationary blade spinning in a table, and you have to push the piece of wood being cross-cut through it, either with a cross-cut sled or a miter gauge, and you've got this long board hanging off the end of the table. It tries to tip on you, and you're trying to fight it, hold it down to the table, push it through. It's awkward, it's inaccurate, and the board inevitably likes to twist, which could cause it to kick back, so it's not the safest thing ever. Here, a long board is no problem. I put it up against the fence. I have this countertop for support over here. I have the other Radial arm saw for support over there. If they weren't there, I could easily rig up a set of sawhorses or 2x4s to hold the ends of the board, because it doesn't have to move. It just has to not flop off the end, and then I can simply cross-cut the thing. Same thing with mitering, same thing with dadoing across the workpiece. I can make half-lap joints, all this stuff where the wood stays stationary and I move the saw through the cut. Now, people will be saying, well, what about ripping? Well, I do a lot of ripping on the Radial arm saw. I still have 10 fingers. It is safe and accurate if you know how to do it. And if you're curious about using the Radial arm saw, I would recommend taking a look at my video on how to use the Radial arm saw. We go over proper ripping technique and stuff like that in the video, how to raise panels with it, do all sorts of things. As long as you know what you're doing with the thing and you have a good Radial arm saw, it is accurate and it is safe. There's a lot of misinformation out there from people who may not know the proper way to use the Radial arm saw. And yes, if you use it wrong, it can end really, really badly. But any power tool used without the proper knowledge will end really, really badly. If you use it correctly, you have it tuned up correctly, that's the other thing. You've got to make sure these things are set right, otherwise they're not going to be accurate. And yes, there are a lot of little adjustments that have to be done. But if you have a high quality saw, once you do those adjustments, short of backing into it with a truck, it should hold those adjustments. Every now and then I hear comments about how somebody locks this thing in 90 degrees because every time they swing it to a different angle, they can never get it back to 90 degrees again. That's an indication that either something's not set right on your saw, or your saw's a piece of junk and you need a better saw. You want a cast iron saw, one of these old, either Rockwell Delta. Delta and Rockwell swapped names back and forth several times throughout history. So whether it says Delta or Rockwell, if it's got cast iron everywhere, it's probably good to go. Or DeWalt. If the DeWalt saw has a cast iron arm that you can see it's not covered in some sort of plastic shroud up there, you've got a good saw. If it has the name Craftsman in it, there's a couple models they made that were good saws. I don't believe they ever got to the quality of the Delta Rockwell or the DeWalt, but they're not bad saws. However, as soon as they started covering up the arms with sheet metal and then plastic, it was all done. So I would recommend staying away from Craftsman. Go with DeWalt, go with Delta Rockwell. There's tons of them out there and they're very good saws. If you get a good radial arm saw, you learn how to use the radial arm saw, it can do everything your table saw can do and more, butted up against the wall. That's the other nice thing, it takes up less space. And if you saw the thumbnail for this video, I had my other 4 basic tools sitting on top of this radial arm saw, which means I could make a little cabinet under this thing to store the other 4 tools. So you would have all 5 tools that I think are necessary for doing most woodworking projects in the footprint of the radial arm saw. So those are my 5 tools that I recommend anybody thinking about getting into woodworking. And if you agree with me or disagree with me, I would love to hear about it in the comments below as to what you think I should have included. What are your top 5 tools? Anything like that.